So we may start. Hello to our attendees. Welcome. This is Mohi, Sustainable Places 2020 Technical Support. And you might have been hearing us for this whole time because we have already started the broadcast. But then now at 11 o'clock right now is the time that we are officially starting this workshop. Before giving it to Raquel, I may just say that on this tab called Handouts, or documents on your control panel, you can download the materials that our speakers provided for you, and also the agenda, which Raquel and Lola will present to you. All yours, Raquel.
Welcome everyone to the Sustainable Digital Tools for All Energy Actors workshops. Thank you very much for joining this session. You can join and participate the polls that we will launch during each presentation. So please try to answer these questions that we will launch. And also you can address to any of the speakers during each presentation, and we will collect them and answer them at the end of the workshop. And also please try to join us on Twitter with the hashtag #SustainablePlaces2020. So I give the floor to Lola, who is the chair of this workshop from XFlex project. Lola.
Hi, hello everyone. Can you hear me? Hello? Yes?
Yes, hi. Lola.
Hello, good morning everyone, and sorry if I have some problems with the sound because it seems that my internet connection is not very good today. Thank you very much everyone to join this workshop. As Mohadis and Raquel already introduced, we are going to present 5 projects, Horizon 2020 projects, all related with digital tools for all the energy actors of the smart grid. We will present the projects before, and then you can share your questions to us. We will also share some polls to you, and then let's try to make it as most dynamic as possible. Let me show with you the agenda, and also to introduce you the speakers of the session. Sorry. Okay, here in the agenda we are. First of all, yes, we will present the agenda. Raquel Castanan as this XFlex dissemination leader, and myself, Lola Lacreu, and XFlex project coordinator. Then I will present you the main objectives and XFlex project, which is flexibility service promoting cooperation among all the energy stakeholders. After that, Pablo Agustin, PhD coordinator of HOLISDER project and research about Technalia, and Mila Vukovic from Serbian pilot location coordination of HOLISDER will present the HOLISDER project. After that, Antonis Papanikolaou from Flex Group, which is Flex Group technical manager and project manager of Hypertech Energy Labs, will present Flex Group project. Then Synergy project will be presented by Luis Biguer, which is a project coordinator and senior project manager and Trainmaster. Finally, Prodromos Mark is project manager of FlexGrid project and senior researcher of ICCS will present FlexGrid project. We will, as Raquel already introduced, we will send polls in the middle of this presentation. And after that, we have some minutes, about half an hour, in order to have questions and answers from your side, and a round table, and finally a conclusion of the wrap-up session. Well, we have more information about the speakers here, but I don't think it's, I mean, maybe it's too long. I prefer the partners itself, the speakers itself, to present themselves if they want to include more information about before that. Raquel, if you want to introduce something else about this, about the session.
Yes. Sure. Well, before the session, we will want to actually launch to the audience some questions just to get some information from the audience. So please try to answer the question that we are going to launch. So first question I will launch. So you can now vote. Well, I will stop this poll because most of the 90% of the attendees have already voted this question. So thank you very much. So yes, so it's 50-50 actually. So 50 of the attendees of the audience have ever heard about these projects, and the rest no. So well, we will introduce and we will give you more details about these projects. So let me launch another question, last question for this welcome session. So please try to answer what is your energy sector. Just to give us an idea. No, I will let you 10 seconds to answer, and we close this poll. Okay, we will close the poll. And so yeah, most of you came from academic of technological center, 68%, and 60% industry sector, and 16% of other energy sectors. So yes, thank you very much for participating. So yeah, now I give the floor to Lola, who is going to present the XFlex project. Lola is the project coordinator of XFlex project. And Lola?
Yes, can you hear me now?
Yes.
Hello. Okay, thank you very much, Raquel. Very interesting to know from which type of sector you are coming. I think most of you are from technological center and universities, so we can adapt our presentations to this. Also a pity to know that no one from any distribution or transmission operator and retailer are in this session, but yeah, it's a pity, but it's like this. So we can, yeah, as I said, adapt a little bit our presentation to this. Thank you, Raquel. So as said before, I'm Lola Lacreu, project manager from Metra and coordinator of XFlex project. I wanted to present a few slides about this project. It's a project that started in October last year. That means that we have just finished our first year of the project, and we have still three years of project. That also means that unfortunately we don't have yet results to present to you, but only some objectives, some tips, and the main activities we are now processing, but not yet the conclusion, so to say. This will be done in the next years, probably as well in this as part of this event of sustainable places. The project is coordinated by ETRA, as explained before. The consortium is formed by 12 different partners from 6 European countries. You can see this in the map from Spain, Greece, Cyprus, Bulgaria, and Slovenia, and Austria. We have also different types of end users and other types of actors. Specifically, we have 3 DSOs, 1 microgrid manager, 1 TSO, 1 battery provider, 3 IT providers, and 3 academic partners. As you see, we have most of the actors of the energy value chain. Demonstration activities will be held in the 4 pilot sites in 3 European countries, which is Slovenia, Bulgaria, and Greece. We'll see more details later. The budget of the project is 9.5 million euros, and the funding is 7.3. What we do in this project? What are our main objectives? Our expectations is that this to develop as part of the project, some of them from scratch, from other based on other Horizon 20 projects and products, the tools that will facilitate the flexibility in the power system, with the main objective of improving the stability and security of the network. In normal conditions, but also we will demonstrate also these tools on extreme weather conditions. Some of the pilot sites are dealing with some harsh winters, for example, with snow, with wind, and one of the main actions and topics of the project is to demonstrate it in these extreme conditions. However, we are not going to demonstrate only the technical part of this issue of these tools, but also the economic and social benefits that we will create with this. As you can see in this slide, sorry, I'm not going to show this slide, but this one. We are including all type of not only actors, but technologies and part of the network. So we are providing not only benefits for all of them, but also involving all type of technologies, including flexibility units, including batteries, PV systems, other systems that are converting electricity into the heat and cold, also electric vehicles, and in a different part, also other types of storage technologies, different varieties of sites, technologies, and services. As I said before, we are covering all the value chains from a consumer side, which is low voltage network, including DSO and microgrid operators, but also the part of the transmission network, and specifically the relationship and the collaboration between all these actors. To do so, we are developing, we are now in the design phase, but of these 3 complementary products, what will offer services and advanced functionalities to all the actors of the energy value chain. This includes ServiFlex tool, which is the tool for the, well, we will see the details before, Service tool, Grid Flex tool, and Market Flex tool. The ServiFlex tool is the tool for facility managers. What we're doing with this tool is to optimize, to manage, to take advantage of the energy storage along with all the monthly flexibility resources in order to take the best from this flexibility not only for the operators of the network, but also for the final consumers. On the other side, we have this GridFlex tool, which is the tool specifically for grid and microgrid operators. The aim is to prevent and to avoid congestions of the network, mainly related with voltage and intensity issues, and also to avoid the problem quality of the network. Of course, increasing at the same time the share of renewables into the grid, and as I said, giving special attention to the impact of extreme climate events. The main point to this is to avoid investment of the network in order to avoid these problems mentioned before on congestions, but using only the flexibility that the systems, the flexibility systems mentioned before, are able to provide to the grid. And finally, we have this tool for final consumers and intermediate parties in order to commercialize with the energy and to provide benefits, economic benefits for all the ancillary services, for not only for DSOs and TSOs, but also for final consumers and intermediate actors such as aggregators. Where we are going to implement these tools and demonstrate them. As I mentioned before, we have 4 different pilot sites, 4 pilot locations, 2 in Slovenia, which is Raunek na Karosken, and Luce, 1 in Bulgaria, which is Albena, and the last one in Shanxi. Different types of locations. Some of them are small villages with very specific problems, as I will show you later, and also all others quite big cities like Shanxi in Greece with completely different issues and different problems. The demo site in Raunek na Karosken in Slovenia is for the one that don't know this site, is a small remote town with a population of about 7,000 inhabitants. It's a specific, it's very nice site because they have a very complete district heating system, and not only for residential but also for industry. And what we want as part of the project is create synergies with this heating system, with the heat production by means of renewables and the heat and network operations. What we want with this is to provide more flexibility to the grid that will lower the imbalance of the network, improve the reliability and security of the electricity, but also supply. And we will also demonstrate because we have 2 different DSOs in this pilot site, and so we will be able to demonstrate the cooperation among the different DSOs, but also distributions and transmission operators. In Luce, it's a smaller remote pine village with only 400 inhabitants, also in Slovenia. They have a very low local network capacity with middle voltage overhead connection with 2 main problems. They have very limited local production of renewables, and they have quite a lot of problems due to these very harsh winters with weather events, so they have frequent power outages because of this. So what we want with InexFlex is to improve the flexibility of the network or the local energy community they have by means of the use of different flexibility resources like community and home batteries they have already, PV panels, wind systems, and also electric vehicle charging points. That will also improve the network, reducing cost and improving the operational reliability. We have also the pilot site of Shanxi in Greece. Shanxi is a quite big city compared to the others smaller pilot sites with 60 inhabitants. They have specific problems with the harsh winters and extreme weather events, including snowfall and stronger rains in winter. So what we want is to facilitate the operation of power to gas and the use of storage devices. We will, as part of XFlex, we are implementing big batteries at a part of the microgrid that will contribute, that will improve the resilience of the system. As I said, with a specific and highlighting our specific objective of improving it under extreme weather events. And finally, this is also a very nice demo site in Albena, in Bulgaria. It's an area of the Black Sea coast, which is an entirely hotel resort, as you can see in the picture. So they have the specific situation, and they are really active in summer, with more than 20,000 people during summer. But in winter, they have only open this very specific for a specific event like Christmas. So they have it's a very nice demo site because it's possible to demonstrate in real conditions the fluctuating energy demand through the year. As I said, it's very different the situation in summer and in winter, specifically for the hard consumption, the big consumption of the domestic hot water they have. So the plan of XFlex mainly is to provide solutions that will provide flexibility to the non-electric boilers and storage systems that will reduce and not only reduce the consumption, but also to make the core flat, to flat the core, so to say. So this is all about the XFlex project. So thank you very much. As said before, you can send your questions from the chat, and we'll discuss at the end and during the roundtable. Thank you very much.
Thank you, Lola. Well, to end up with this presentation, I would like to launch just a question. So, what are your interests in this type of project? What benefits do you think you could get from this project? So, please try to answer this question also. So you can vote now if you want. Okay, I close the poll right now. So yes, so this is the questions that you have answered. So 40% want well, reduce cost, that they are interested in reducing cost. The other 40% it's interesting in reducing environmental impact. 24% improving the network stability, and 70% on finding out lessons learned from other R&D projects. Well, as you know, all the projects have already a website, and they are sharing all the lessons learned that they are finding out during the process, and you can check them out this information on the website, or even contact them directly. So now,
just one comment, Raquel. Maybe
yeah, so,
it's in order to network problems, we can just turn the camera of the person which is talking at that time. What do you think?
Sorry, I couldn't understand you well.
Don't you hear me now?
Yes, now yes, sorry.
Sorry, maybe I'm thinking problems with the micro. In order to avoid problems with the network connection, maybe it's better that only the person which is presenting at this time is sharing the camera, showing the camera.
Okay. So yes, so now it's time to. So yes, thank you. So yeah, after this presentation from XFlex, from Lola Lacreu, I would like to introduce Pablo and Milan. They are going to present a HOLISDER project. So thank you very much for for participating. Before of that, they have prepared some questions also. So please try to answer them. They need some information also about you, about your thoughts on different issues. So here's the first question. Which link of the energy value chain is your main interest activity in? Okay, I will give you a couple of seconds to answer. Okay, so most of you it's the building manager, ESCO and building managers, and yeah, the 42%, and then the 25% is retailer and aggregator. So yes, next question. I will try to do it as quicker as I can. Sorry. So the second question, it's which are the main enablers required for spreading demand response programs among the tertiary and residential buildings? Well, I close the poll. So let's see your answers. Sorry. So yeah, most of you yeah answer attractive business models, the 80%, and the 40% transparency and clear rules for clients' rules of the game for all. And just a third question to start with this presentation. So if you could optimize the use of HVAC and loads in your building home under demand response perspective, what would you prefer? Oh, yes. So here are the answers. So yeah, the 43% vote automatic control that you can override on any moment, and the 36% recommendations provide so you can take decision. So thank you for voting. And now, yes, I give the floor to HOLISDER speakers. Thank you very much.
Thank you, Raquel. can see my screen properly, right? Presentation. All right. Well, thank you everyone for joining. As Raquel mentioned, I'm going to present the HOLISDER project, which is a project finishing next spring by March 2021. It's a project on which its main, well, title actually, it's integrating real intelligence in energy management systems, enabling holistic demand response optimization in building industry. And in particular, although the project covered different aspects of the whole energy value chain between the domestic and tertiary end user of buildings, the building management, and what happens toward the grid. Today, we will be focusing on what the project has done regarding consumer engagement visualization platform and toolkit, and the demonstration in the Serbian pilot site, which is the one more oriented to the residential consumers. Before going in details on this Serbian pilot site, as a little nutshell of the project, well, it's aimed to face the challenge that as the energy market is getting more decentralized with more distributed energy resources and more flexible, there was this the demand response schemes seem a way to facilitate the balance between the demand and the generation. Not only, as always, the balancing is from the generation side, but also from the demand side. But there were this, even maybe industry and some main energy consumers are already participating in this type of programs across Europe. Small and medium buildings, especially tertiary and residential buildings, are not active players in the energy market, right? So the project aimed to solve from two sides is this gap on how to engage this type of end users in as active players. From one side, enabling all ICT interoperability issues that had to be faced for a whole interoperability between grid, building, and intra-building or intra-home equipment, appliances, etc. And on the other hand, well, how to present more attractive business models or tools to make this consumer empowerment, how to translate this concept as flexibility or elasticity or aspects of the grid that are totally or complicated for especially a residential consumer, but also from a small tertiary building consumer whose business or whose day-to-day worries are not related to the energy market, right? And the project is facing or is being demonstrated right now in this last semester of the project in 4 pilot sites. We have some office buildings and domestic consumers from the project partner, who is a main electricity utility in Athens, Greece. We have a demand response aggregator in UK that is bringing from their portfolio of clients a commercial and residential buildings in London. We have a professional building management company who is providing commercial and residential buildings in Helsinki. And we have also the main public district heating company in Belgrade, Serbia, with a large residential neighborhood. As I mentioned before, we will be focusing on it today. In any case, there is also in Sustainable Places an associated poster that you can see on on the documents attached to this webinar. And also, once the Sustainable Places proceedings are published, there is a conference paper that gives a wider overview of the whole project. But as I said, going maybe in some technical details, at the end, HOLISDER provides a framework of software and hardware components that aim to enable demand response implicit and explicit schemes from building level, even apartment level, toward the grid. And there are different analytic tools oriented to different end users, from some outputs, all based on the data generated in the buildings, but some tools are oriented for energy retailers or aggregators, and others to building manager or to domestic consumers. As I said before, today we will be focusing on these components oriented to residential end users. So now I give the floor to my colleague Milan from Velit, who will make the introduction to the Serbian pilot site.
Hi everybody, Milan Vukovic speaking. I'm a Serbian pilot site coordinator from Belgrade, Serbia. As Pablo said in the introduction, Serbian pilot sites consist of 3 buildings that are located in the Belgrade STEPANOVIC neighborhood. It's a rather new part of the town, which is located 5 kilometers from center of the city. It was built in the 2010 and 2012, between those years. It has 42 acres of area and has 44 buildings with 4,600 apartments. Here on this small map, you can see the location of our buildings that are included in HOLISDER project. We have 2 residential buildings with general names here, and we also have a primary school, Danilo Kish, also located in the neighborhood. So we can move on, Pablo, please. Main goals of the HOLISDER project in Stepa Stepanovic location is firstly, it's one part of the whole goals of the HOLISDER project. It's monitoring and visualization of data of consumed energy, devices and sensors. Then we also try to analyze the change of behavior and awareness of the consumers and end users that are living in this area. So I'm very glad that also you as an audience recognize the goals by answering previous 2 questionnaires that were presented to you. So user empowerment and user awareness is really our focus on this project. Then personalized informative consumption monitor will enable useful and active participation in the tariff systems, and also further control of consumption and monitoring and managing installed equipment. We can move on, Pablo, please. So now you will see the pictures of the 2 buildings that are included. These are 2 residential buildings. They're pretty much similar to one to another, and we also have a primary school, which is on next slide. Thank you. And this is primary school Danilo Kish. How to reach our main goals? So we on our pilot location we had mainly analogic meters, and our project deployment plan also included installment of the new equipment that increased significantly the smartness of the buildings and the quality of data that can now be obtained. Also, data is now possible to present in the different diagrams or on mobile and web applications. I will show you the screens after. And also, we have now possibility to hourly and in real time see the heat consumption and to collect data from heat consumption. Also, there is possibility of remote monitoring of various devices for heating from the substations, reading controllers, calorimeters, etc. And also, we are now trying we now have possibility to use the different tariff of energy that are presented. For instance, we have heat energy which is fixed, but we can combine heat energy that we got from the remote heating system with the electricity, because the price of electricity has a different price according to periods of the day. So this system enables users to choose which energy to use for heating. Also, we developed new mobile applications when users have overview of electricity and heat consumption, and they can get warnings and useful tips. So we also have some automatization regarding the heating, but also we gave end user now possibility to make his own decision of which source of heating can he use in his apartment. So can we move to next slide, please? Here we see the data that can be obtained in our pilot locations. This is sort of a triangle when at the bottom we have the general information about the heating plant in Voždovac and the capacity, and each of these parts of the triangle has different set of data that can be obtained. So as we move along this pyramid, we are going to the top where we can see the improvement of building smart readiness. So settlement STEPA STEPANOVIC has possibility to see the consumption of building level, and the frequency of extent of reading is monthly for 55 substations. Then we have a next number of buildings that can have more data, and so on. So at the end we have the next slide. We have an overview of the heating plant Voždovac, and this is schematic drawing of the distribution system of local heating plant. Okay, we can move to next one. And this is an overview in what we have installed in each pilot building. So we have here information about which sensors are located in apartments. Okay, and on the next slide, we can see the next slide, please. one more, I think. Okay. Sorry, I was. You can now see some screenshots of the mobile application which we developed on our project. Mobile application gives direct insight in comfort parameters and energy consumption in the apartment. Mainly, they get information about the temperature, about humidity, electricity consumption, and the heating for the whole apartment. Data that is shown in this application is collected directly from the equipment which we install at the apartments. So it provides also users with the statistics for energy consumption, for both energy consumption about heating and electricity consumption in the they can choose to show the consumption in selected periods, and as well as comparison between different selected time periods. And more so, on this slide, you can see the mobile application also present the status of some heat consumables in the apartment. Here we can see the screen for heating, then for air conditioning system in the apartment, and the third is for boiler, domestic heating boiler. So it also give a possibility to end users to directly control these appliances, and they can use their mobile application to turn it on and off. Also, our mobile application also provides tips, instructions, and information to users that are relevant in that moment or in general. So they can see the weather forecast. They can also get the advices regarding the heating, like heating tips. And also they can see different statistics about their specific consumption. Okay. Also, in parallel with the mobile application, all the end users have possibility to see the web portal, and to also view in form of diagrams their consumption, and by different energy users in the apartment. And we also are very proud that during the whole project we have a very good communication with both building managers and end users, and we held several workshops for the end users. The last one was held a few weeks ago. We, of course, because of the COVID, used the Zoom platform for it, and it was also very good way to promote our project and the goals of the projects. So I think that's it from my side. If you have any questions, please let us know.
Thank you, Milan. Yeah, well, besides these particular tools that we presented today, also in Project YouTube channel, you can find additional information on other tools oriented to other type of end user that we develop in the project. So just to finish, towards the end user, what we are doing in this last semester is we are working some upgrades on the mobile application. In particular, also within the project, as there was an energy tariff emulator developed by Tecnalia. We also adapt it to the needs of this pilot site, where we have a heating system that is the district heating with a constant price, But on the other hand, buildings, many of the homes are also equipped by heat pumps, usually split heat pumps that they install for air conditioning, but that can be used also for heating. So right now we have developed a energy cost calculator for domestic space heating, and we are working with Velit to integrate it in the app. Let me just to finish make you a short demonstration on what it is the concept of the demand response in heating. It's within a home, we think is what the heating or the air conditioning energy use are the ones more suitable for flexibility or for participating or taking into account for demand response. So what we have developed is a heating cost calculator that compares the cost of the heat hour per hour depending on the technologies used. So you introduce the location. I'm sorry, right now in this demo is only prepared for a Spanish weather service. So because it will take into account the weather forecast for tomorrow. This is a 24 hours ahead calculation. You say how many heating systems you have at home. In case you have two. You can say that you have, for example, a heat pump and a gas boiler. You introduce your prices of the gas, for example, which type of heat pump you had, choose the type of refrigerant it used. It will affect a little bit to the coefficient of performance of the heat pump, and you define which is the electricity tariff you use. In case you have just a fixed tariff, the only variation will be affected by the because this is the cost of the heat delivered into the home. So even if the electricity is a fixed price, the coefficient of performance of the heat pumps varies along the day depending on the weather conditions. So here, well, I just introduced some dummy tariffs. So in this case, the electricity heating with a heat pump, it will be much more expensive in the cold morning hours than at noon, while the gas is more constant. If you use a real-time pricing tariff, even with night period on it, in that case, the difference of the pricing using the heat pumps along the day is very different. So this is something that obviously, if it is not shown to the end user, domestic end user, graphically and in an intuitive manner, they will not be able to get access to this information. So this is our aim, to include in the app, so they can look every evening, the day ahead, which of the two technologies they have is cheaper to cover their heating demand, and also maybe considering by period of the day, and that's it. So that's it for all. Thank you very much, and just follow the links we include in the slides for additional information.
Thank you very much, Milana and Pablo. As we mentioned before, if there are questions from the audience, please include it in the tool, and we will ask to the person it was directed at the end during the roundtable. Thank you very much for this very interesting presentation. Let's go now with Antonis Papanikolaou, Flex School Technical Manager and Project Manager from Hypertech Energy Labs, will present the Flex School project Automation, the key to unlock residential flexibility.
So, good day, everyone. I hope you can hear me properly and you can see the slides. title slide?
Yes,
Yes.
Antonis.
Perfect. FlexCoop is also a project at a similar level of maturity as Pablo presented before. So we are now in our last months of the project. Contrary to the HOLISDER presentation, which took a perspective more toward the end user, what I would like to share today is more what kind of results we are managing to obtain in terms of flexibility, mainly from residential buildings. So I should note that this is still an exercise, an ongoing exercise within the project. So the pilot demonstrations are not complete yet. But I'll show you some preliminary information that I thought was useful to disseminate. As introduced by Lola, my name is Antonis. I represent the FlexCoop project. I'm the technical manager there, and I work at the Hypertech Energy Labs, which is also a partner in HOLISDER, by the way. So some of the baseline technologies are similar in the two projects. A few words about the project itself. So the project title is actually Democratizing Energy Market Access through innovative flexibility-based demand response tools and novel business models and market models for energy cooperatives. It's quite ambitious. I'll try to give you some insights on some of these specific things during this presentation. So you can see we have several partners from around Europe. Apologies for that. Yeah, I was just moving the box out of the way. So in a nutshell, what are we trying to do in this project? So we identified several problems, well, when the project was starting, some of which have to do with, for example, the lack of information, more specifically real-time information about the energy status of the building. Regulations or market codes were quite limiting in most member states regarding flexibility and demand response, as well as back then the business models were not, well, they're still not proven to be honest. So within the project, what we're trying to do is, well, there's a need rather to make people aware of their flexibility and what the benefits of this flexibility is for the energy system. By flexibility, I refer, of course, to energy flexibility on the power grid in this case. And furthermore, there is a need to leverage this flexibility, as Pablo well explained, in order to implement a scenario where the demand follows basically the intermittent supply of renewables. There's a clear need also for to establish rather contractual relationships between end users and aggregators in a fair manner, because this is a very new field. And of course, in terms of demand response tools, there is a need for automation, and in this case, automation does not mean that ICT tools can take over and let's say not ask the residents, but rather they should be able to provide concrete, or rather just ask for the authorization of the end user to apply whatever set points, for example, they need to apply. So we're not trying to bypass the end user altogether. We're just trying to make life easy for him or her. So the FlexCoop solution itself sees cooperatives as aggregators, and I will go into more detail in this later on. We're trying to implement, well, to demonstrate at least a new business model for aggregators using end-to-end automated demand response tools, and to extract flexibility in a human-centric approach, and I'll explain more what I mean by that. And of course, we need to aggregate this flexibility from several buildings. In terms of objectives, quite similar to before, we need to take into account the people living or working in the buildings, so that we don't violate their comfort constraints. We need to empower basically all the stakeholders in the demand response value chain. Sorry, apologies, I'll just minimize this window. Sorry for that. So we need to develop an automated demand response framework, as mentioned before, with end-to-end interoperability, And we need, of course, as mentioned, also new business models, and to be demonstrated and quantified to the extent possible in order to democratize access to energy markets. In terms of pilot sites, we have two cooperatives in the consortium. One from Spain, from Catalonia. It's Som Energia, a quite old cooperative with many members. And from the Netherlands, we have ODE Decentral, which is basically a cooperative of cooperatives, if you like. And we're dealing with two specific ones, Endona and Escozon, at this moment with the members of those cooperatives. Now, in terms of what we're trying to do with these cooperatives and the business model, so we are tackling two different situations, two different business models, if you like. In Spain, we're looking at the model for a cooperative as a retailer. So there, the challenge more is how to maximize self-consumption. So there is a strong push basically to install more renewables at the residential level, mainly photovoltaics, of course. So there, the main challenge is to try to maximize self-consumption by shifting demand to the times of local generation, of course. And through that, you can also minimize the cost of energy for the residents, for the users. On the other hand, in the Netherlands, we are looking more to a business model of a cooperative as an independent aggregator. And this is something I will dig in further in this presentation because I find this quite interesting. So basically, the target business model there is to provide balancing services to the TSO. And we have actually in the Netherlands, there's this nice opportunity because TenneT, the local TSO, has sandbox balancing market for frequency regulation that's accessible basically by anyone. It's a sandbox market, and this is exactly what we're trying to do within FlexScope. Well, not necessarily to fully integrate and provide the service, but at least using this as a baseline. We're trying to show what we can do with the FlexScope tool. So in terms of the value chain of the solution that we are providing, we start from the buildings at the top, so residential buildings as mentioned before, and there we have fully instrumented these buildings in order to extract the information we need. So this could be from the energy consumption at the house level, the residential level, to consumption of individual assets that are relevant for demand response, to ambient conditions within the homes and so on. And then we have a marketplace, basically a transparent marketplace, where the different buildings can basically bid their flexibility, and of course then an aggregator, who is in our case a cooperative, which has the necessary ICT tools in order to aggregate the flexibility from the different buildings and come up with a bundle that it can bid into, for example, the balancing market that I mentioned before. Now, going to a little bit more detail about the how. So it's clear in our opinion that buildings should be smart in order to be able to provide flexibility. This is electricity demand flexibility to the system. And in order to do that, we need data-driven asset models as well as demand forecasting that are actually fed from real-time data from these buildings. So below on the left, you can see some of the data that we are currently collecting from these buildings in order to be able to come up with a flexibility profile engine and models that can actually provide you an accurate view of how much flexibility can be available by the specific building under specific context and circumstances for the next, for example, 24 hours, so in a day ahead scenario. So to become a bit more technical, what we do is we start by profiling the thermal comfort of the individuals that are living or working in the building, living in this case. So we generate this thermal comfort and discomfort curves. By the way, I will talk about thermal and HVACs from now on. The similar things can be applied to, for example, lighting or domestic hot water and so on. But from now on, the presentation is more focused on thermal aspects of the building in terms of, ambient temperature. So we start on the left from profiling the thermal comfort of buildings, of the occupants of the buildings, and that can give us a good estimation, for example, about where the people feel comfortable in terms of temperature, as well as to what extent they're willing to sacrifice a little bit their thermal comfort, which can then translate, of course, into demand flexibility. Now, on top of the comfort profiling tools, we are also building tools to basically establish and project the thermal dynamics of the building, so thermal inertia and so on. This is very important because basically buildings are large thermal batteries, if you like. By, for example, preheating or pre-cooling, you have a way to shift energy consumption, and in our case, electricity consumption. So this is one of the main things we leverage in order to come up with demand flexibility. So, but in order to do that in an accurate manner, you need to be able to forecast, for example, in this case, the temperature over a significant amount of time in the future, so as to be able to maintain thermal comfort. So, and finally, what you need is a model for the HVAC system energy consumption, so its demand profile. Which is also quite challenging because different types of HVAC systems have, if you like, different demand patterns. But all these models need to be created, calibrated, trained, and running at real time in order to come up with an estimation of the flexibility of the building. And this is just an example in a nutshell, showing how these things work together. So I will not go into too much detail here, but basically what you can see is the horizontal lines are basically comfort boundaries, and they can be higher due to, for example, non-occupancy, or more narrow because people are in the building. And you can see the temperature profile within the building. One is the simulation, the black line. The purple one is actually the reading got obtained from the sensors. And then, of course, we also have the actual power consumption of the HVAC system in the dotted green line, and the solid red lines, the simulated one. So basically what we're trying to do is forecast as well as possible how the building is going to behave under the expected conditions. So this could be a baseline, as well as see in which time instances we could deliver flexibility from that specific building. So if you have a baseline consumption of the building, then it's possible to also evaluate when you can reduce or when you can increase the energy consumption. Now, simulating basically the models I just mentioned into, let's say, a weekly profile, if you like, provides these results. So this figure shows what one given heat pump from one of the buildings of the FlexCo pilot sites in the Netherlands can deliver in terms of flexibility in time. So the top figure basically shows you the absolute demand of this heat pump, and the three lines correspond to three different temperatures inside the home. So if you have, of course, a lower temperature, in this case you have a lower consumption. This is a heating scenario, obviously. On the other hand, a higher temperature requires a higher energy consumption. But what's more interesting is that on the bottom two figures, you can see from one single heat pump how much flexibility is available if you go for regulation up or regulation down. So you can increase the energy consumption of that specific heat pump by so much if you need the regulation up capacity, or you can decrease it by so much in a regulation down scenario. So this is essentially, such information is what is useful for an aggregator in order to evaluate, on the one hand, if the specific building with specific assets can deliver demand flexibility, but also in order to evaluate how this can participate in a virtual power plant or in a bundle that can be eventually bid in a market. Now, going to this tenant market I mentioned before, we found this to be a very nice, if you like, application area for the tools we have developed and the activities of FlexCube. So these three figures just give you in a nutshell some very simple characteristics of the market. So keep in mind, this is a 3-year duration on the horizontal axis. So on the top, you see basically the remuneration of this market. So the orange line is the standard day ahead market. Well, the price on day ahead market, spot price. And then the green line shows you the remuneration for the specific market for frequency regulation. So this already tells you that it's beneficial if you have flexibility to use it in this market rather than to use it in day ahead scenarios for basically for cost minimization, for example, for the detailer or other kind of strategies. The middle figure shows you how often rather this flexibility was activated by the market operator. And you can see this is quite a busy market. So it's not always, because again, this is a 3-year time frame, but you can see that this market requires flexibility quite often. So there will be opportunities to actually be remunerated. And finally, the third figure shows you the actual remuneration from the specific market per megawatt. So this is euros per megawatt, and this is actually the real price that an aggregator can obtain if he bids 1 megawatt and that bid is accepted and then dispatched by the market operator. So in a nutshell, this looked like a nice market to focus on in order to demonstrate what is the actual value of what we're doing in FlexCube. Now, this is another simulation. What could a single heat pump
Sorry,
do?
Antonis,
Yes,
sorry, but if you can just go a little bit quickly and wrap up.
Yes. Yeah, perfect. Okay. Yeah,
minutes.
Sure. 1 minute still. So this is what a single heat pump could do within our demonstration. So you can see this is 1 week, and you can see the demand profile and what could be potentially the remuneration from a specific heat pump per megawatt if bundled and bid in the market, as well as the remuneration of the specific heat pump. So this just gives you an estimation of the value of one home. Of course, this should be aggregated then and bid as a bundle to the market. And finally, my closing slide, we're also performing some trade-offs regarding how much flexibility is available from thermal loads if you do them in a manner that's comfort aware, or if you just shut them down, for example, what's needed. So you can see on the orange line, you can have a lot of flexibility and a lot of remuneration if you just shut down your heat pumps when the grid demands it. On the other hand, this green line shows you what you can obtain in terms of revenues if you do it in a manner that respects the comfort preferences of the people living in that building. So this is also a very interesting trade-off, at least in my opinion, that could be explored further. So this was actually my last slide. Thank you very much for your attendance. And if you have any questions, feel free to ask.
Thank you very much, Antonis. Very interesting presentation. Well, just to remark again, questions, please include in the tool, and we will send it to the person in charge at the end. Thank you very much. Now it's time for the presentation. Thank you, Antonis. To the presentation to Luis Viguer, Energy Project Coordinator, Senior Project Manager at Netra. And the name of the presentation is Big Energy Value Data Value Creation within Synergetic Energy as a Service application through trusted multi-party data sharing over an AI Big Data Analytics Marketplace. Please, Luis, when you want us.
Yes, I would like to. Hello, everyone. Just Raquel, if you can launch the poll first of all, and then then I can start with the presentation.
Yes, the first question from Synergy will be, what is the main obstacle in relations to today's grid infrastructure for a successful energy transition? Well, I will let you a couple of seconds more to answer the question. Okay, I close the pool. So this is the result that we get. So 47% says that too little flexibility available. The 24% the opportunity to offer load balancing services, and 18% missing cross-border trading options. So next question will be this one. What is the future of the green energy transition going to mean for tomorrow's grid infrastructure? Well, I will close the poll right now. So it seems that all of you are agree, more decentralized production. And last question here. What level of legislation is required to ensure a successful energy transition for you? Well, I will close the poll right now. So yeah, most of you consider that flexibility market to be completely open across Europe, and 25% thinks that green certificates only to be sold were generated. Thank you very much for participating, and yes, I give the floor to Luis. Thank you.
Thank you very much, Raquel, for your support, and thank you everyone for collaborating in the poll. So I guess you can see my screen. I'm gonna make it full screen. Okay. So I'm gonna present you the H2020 Synergy project. Okay, there is a project focused on the big data energy value creation with synergetic energy as a service applications through trusted multi-party data sharing and artificial intelligence big data analytics marketplace. So my name is Luis Biguer. I am project manager at ETRA, and currently I'm a project coordinator of Synergy. So the overview of the project. This is an innovation action, okay, towards digital transformation. What we pretend is to bring big data solutions for energy sector. So this is going to be done by introducing a novel framework and reference architecture, okay, for big energy data platform and artificial intelligence analytics marketplace, okay, and we are going to bind this together with data-enabled specific applications that will be built on top of this big data platform, okay. So with these applications, we try to cover some necessities of that are arising lately in the electricity value chain, okay. The project has almost a total budget of almost 13 millions with almost a total funding of 10 million euros. It started 1st January 2020 this year, and it lasts 42 months, so it will end by the end of June 2023. So why we decided to take up the challenge of synergy? Okay, we are seeing the smart grid era is here. Okay, everywhere is everything is going to be or is already being monitored. We are developing and deploying from smart meters until smart sensors. We are deploying them throughout the whole electricity value chain. Okay, so these are new data streams that we can make use of them, okay, to enhance the current energy services. We also have identified some potential benefits, okay, from corporate services in the energy sector, okay, that can be enhanced with AI big data analytics solutions. We have also taken into consideration that there is, besides the new data streams, there are also a lot of them that are actually hidden. So we want to put them into value, okay, in our big data platform. Also, we are facing a new era of decentralized energy resources, let's say virtual power plants, virtual storage plants, aggregators, and so on. So these new business functions, okay, we will be also taking into consideration, and then we will also provide added value to their businesses. And finally, what is mostly the cornerstone here is the data exchange, okay, between electricity stakeholders is for us a key factor, okay, to make sure that we provide non-discriminatory and transparent and secure data, and also the exchange of data is doing in such a way, okay, for the platform users. Okay, so the main targets of the Synergy project, okay, are first of all to deliver the big data platform, okay, that is going to be fed by energy-related data from all the energy value chain, you know, from generation until commercialization, until retailing. Sorry. So the second one is to integrate, okay, all these big data technologies that are arising lately, okay, tools and libraries, and put this together with energy legacy systems that are quite common already in conventional generation, most of all, but they are still remaining in a lot of places. So this is for sure a huge work that we have ahead, okay, to try to merge both types of data, both types of technology, okay, to put them to work together. The number 3 is also to respect the intelligence property rights since we are going to work in multi-party data exchange and sharing frameworks, okay, we also have to make sure that every party is respecting its IPR issues, and also we have into account the security and the privacy, because we are also considering the GDPR in our developments. So the next one is also to enable the delivery of innovative services, okay, to add value to what we already have in the energy sector, okay, so that all stakeholders can benefit from this. We are also developing some innovative business models, okay. We would like to focus on the collaborations and the data sharing between the parties, okay, so that this big data platform has a real impact, okay, in the energy sector. We are also have a really challenging target, okay, which is to become a reference big data platform architecture. Sorry. So we are working on this, okay, currently, and we are going to demonstrate the project in 5 large-scale demonstrators, okay. All of them are quite different from each other. I will present you later. And so with this, what we pretend is to make sure that this reference architecture can be implemented elsewhere, you know, at any place, at any company, at any business environment. And for sure, what I was saying was related to the last target. Okay, we want to extend the adoption of the synergy solution. Okay, we are also want to make these energy as a service applications that are running on top of the big data platform. Okay, to become world-class solutions for the energy sector. So the consortium is of Synergy is composed by 24 partners from 9 European countries. Okay, we are covering all the value chain of the project, from applied research, analytics, and big data expertise. We also have, for sure, end users from the energy sector. We have TSOs, DSOs, renewables operators, retailers, aggregators, so on and so forth. So as you can see, we have been able to cover 3 strategic areas of the project, which are the energy systems and services, the big data analytics, and the business innovation and energy markets. Okay, so we have been able to put together all these 24 partners. Okay, we have 1,700 person months, okay, to accomplish our duties. That's like having one person working non-stop for 140 years. So we have to do that in 3.5 years. So we have, yes, a lot of work ahead, and but also a lot of resources for doing this. So as I promised, the 5 pilot sites, let's say, where the demonstrations are going to be held, are in Spain, where we are dealing with retailers, but also with small DSOs, and most importantly with RES operators and buildings. Okay, in Austria, we have also the buildings, the energy certification, the renewable generation, and the electric vehicles into the pilot. In Finland, we have large corporation energy certification. Large corporation buildings, energy certification for buildings as well, and the electric vehicles. in Greece, what we have is the power grid stakeholders, TSO, DSO, but also we have large industry consumers and building consumers, and the renewable generation. And finally, in our piloting Krk, in this island, this Croatian island, we have also the households and the large buildings, and also the renewable generation and the energy certificates. So what we have in mind, okay, with these large-scale demonstrators, is to involve diverse actors and data sources. You know, this is going to be really heterogeneous, because we have several companies and several public entities working in each of the pilots. Okay, so we also have, as you can see, we are covering from the north of Europe until the Mediterranean area. So we have set these pilot sites, okay, in order to facilitate the replicability and scalability of the solutions that are going to be developed, and of course to maximize, okay, the market opportunities that we are going to look for. So the project, okay, is going to actually deliver 3 tool suites. Okay, the first one is the advanced grid level analytics for optimized network and asset management services and applications. Okay, this is, as you may know, more related or focused, let's say, to system operators. Okay, some energy applications that we are considering here is to have collaborative scheduling and network management, asset management, network planning and infrastructure sizing, and energy and flexibility trading. Okay, this is more, let's say, for TSO, DSO collaboration and related entities. Then we have the second level where we are focusing on the portfolio level analytics for energy as service applications for electricity retailers and aggregators. So we are delivering here energy applications focusing on flexibility contracts management, flexibility analysis and virtual power plants, self-consumption energy management, some innovative customer services, and portfolio analytics for both retailers and aggregators. And finally, the last tool suite is focused on the building and district level analytics for optimized energy performance management. So here, what we're going to deliver is the energy management, predictive maintenance and self-consumption app, building certification app, renovation design, and urban energy management and planning applications. Okay, so as you can see,
sorry, Luis, sorry to interrupt you, but we need you to be really quickly and wrap up in a couple of minutes, please.
Okay. So I will be finishing. Thank you, Lola, for advising. We're gonna take into account 2 data, well, let's say data assets. Let's say where we have called this data tier. Tier 1 is going to be from the primary energy sector data. And data tier 2 is going to be extra energy data, let's say support information about market, weather, and so on. Okay, I don't want to go into much detail since I am running out of time. And we are presenting some novel aspects within the big data platforms and energy data sharing. We are very committed to the privacy, to the security, to the reliability of the data. Okay, this for us is a key point in the project, but we also want to make this user friendly. So it's going to be easy. We're going to work hard to allow end users to easily link different types of data, to have some intuitive experience in the apps and in the platform, and well, to provide world-class solutions to the energy sector. That I think we will be able to do that with all the data we are gathering from the different pilot sites. And I think that's all. I will be happy to answer your questions lately, and please follow us in the social networks if you have enjoyed our presentation. Thank you very much for your time, your attention.
Thank you very much, Luis. Very interesting. To finalize with the presentations before going on to the roundtable, let's go with Prodromos Makris, FlexGrid Project Manager and Senior Researcher from ICCS. The name of the presentation is FlexGrid Project Integrating Advanced Intelligence in Existing Digital Tools of Energy Market Stakeholders. Please, Prodromos.
Yes.
We see a Word document in this moment.
Now you should be able to see my
screen. Yeah, we see the slides, but not in a complete screen. But, well, we see it well anyway. Now it's perfect.
Perfect. Okay. So, hi from me. I'm Prodromos Makris, and I represent the Institute of Communication and Computer Systems from the National Technical University of Athens. And I'm going to present to you the FlexGrid project. So, what is the research motivation behind the FlexGrid? I could summarize it in these 3 bullets that you see in red. So, there is a need for high and distributed renewable energy source penetration. So we have this intermittency, non-dispatchability, and stochasticity features of the renewable energy sources, and especially in the distribution network. So we need to deal with the distribution network challenges, for example, local congestion management and voltage control. And we also want to make small energy prosumers and small flexibility assets residing at the distribution network side to be able to participate in the existing energy and the emerging flexibility markets in order in this way to facilitate bottom-up investments in flexibility assets. So we have this first aspect. The second aspect is the need for energy markets liberalization, as you may all know, based on the EU agenda, political agenda. So here we need to open the market to various market stakeholders, and we have various roles and conflicting interests between them. So all of them want to maximize, let's say, their profits, but from a system level perspective, we want to maximize the social welfare. So it's a matter of research to understand which architectural solution is in favor for specific players, and to quantify this, how much each player gains or loses in a specific market architecture settings, both existing ones and the ones that will be a reality in a few years from now. And the third motivation is about the need for sustainable investments and optimal exploitation of flexibility. So we want to use as much flexibility as possible within the next decades, and to rely on renewable energy sources and flexibility assets as much as possible, based again on the political agenda of the European Union. So here, the main thing is how can system operators utilize efficiently the flexibility provided by the distributed flexibility assets in order to avoid more expensive grid reinforcements. The second issue is how can flexibility suppliers optimally invest and operate their flex assets to maximize their profits, and also how to incentivize end users at the demand side, small energy prosumers, RES cooperatives, RES communities, to buy and utilize distributed flex assets in the future. So the main innovative research idea here is to look into advanced mathematical models and algorithms. We know very well that there are many tools within the Horizon 2020 projects and in the portfolios of commercial players that have existing solutions in order to optimally participate in the market or in order to optimally manage their network, if we talk about the system operators. But there is a need to bridge the gap between the market and the network, the market operation and the network operation. So the gap that we think we need to fulfill here is that we have a specific distributed grid operation and we want to make it market aware. So in order for the distribution system operator to be able to facilitate higher penetration through flex markets operation. And the other aspect, in the opposite side, we have a specific market operation. So we have existing markets nowadays in Europe, but as you may all know, they are not network aware. So the market clearing that they do most of the times does not take into consideration the grid topology, the dynamic grid topology. So here we want network aware flexibility market operation. So these are the two things that lead us to develop an automated trading platform, which is actually a digital tool in which we want to integrate this intelligence for various market stakeholders. The first one is the flexibility market operator or local market operator, as we call it, which is a new entity, and we want to introduce it in the energy ecosystem. We have the distribution system operator user, the energy or else flexibility service provider, and the independent aggregator user. So we focus on business to business cases, more or less here. And we have here the current situation we have the market operator, we have the TSO and DSO, and now we introduce a new market player here called FMO, as you see in the picture. So there are many discussions nowadays in Europe on how to coordinate this TSO-DSO interaction for better network operation outcomes in high renewable energy source scenarios. So we're trying to see different market architectures for this, but also one innovative thing that we do is that we try to see also the MO-FMO coordination. So in order to model the interaction between wholesale energy markets and the local energy markets. And the ultimate goal is somehow to have an ecosystem that is both market aware and network aware. So we need this cooperation between all these four stakeholders, both in the market domain and the network domain. And we follow up the Nord Pool paradigm that we have in the project. So as you all know, we have the day ahead energy market, the reserve market, and the near real-time balancing energy market. So the question here is, okay, but what are exactly the inputs and outputs of these 6 markets that we propose? So we propose a superset of 6 markets, the three existing ones that we already have for the transmission level. We copy and paste them in simple words in the distribution network level, and we want to see which market sequence of these 6, which combination of market sequences gives the best results with respect to specific key performance indicators. So we have these three market variants. The first one is called reactive distribution level flexibility market. So here we have a flexibility market at the distribution network level that follows up the results of the existing day-ahead energy market. And this is compatible with the existing regulatory framework, but still is not optimal because the results of the existing energy market, day-ahead energy market, may not fulfill the constraints of the distribution network. So this is a problem. For this, we have the proactive DLFM, as we call it, in which there is a DN level market that precedes the respective transmission network level markets in order to proactively avoid local congestion voltage control problems. And then we have a more futuristic architecture, market architecture, in which we propose an iterative process until the market operator and the flexibility market operator, or else the TSO and DSO, if we talk about reserves and balancing markets, converge to an optimal dispatch for both transmission network and distribution network levels. So regarding the implementation, we focus on this automated trading platform. We have the flex demand side and the flex supply side, as you see here, and we have interaction with both the existing network topology and the existing markets. And here is the software architecture. You can see with blues the various algorithms and mathematical models that we develop in order to be able to, for example, to compose an optimal flex request from the flex demand side, or to compose an optimal flex offer from flex supply side. And we also have optimal planning models for ESPs, energy service providers. And regarding the digital tools, we have these three tools: the automated flexibility aggregation toolkit, which is actually for the aggregator user, the flex suppliers toolkit, which is for the FSP user, and the flexibility market clearing toolkit, which is for the FMO and DSO user. So we have some specific applications developed in another project in the Wise Grid, and also the nodes, which is currently a commercial company that operates local flexibility market. And what we do here is here in blues, we try to integrate back-end intelligence in these three software toolkits in order for the different market stakeholders to be able to optimally place themselves in the new emerging ecosystem. So here we have for the first toolkit.
Sorry, Brother Ramos, to interrupt you, but I'm really sorry because you are the last one, but we are quite late and we would like to have some questions. So if you could please go more to the point and wrap up in a couple of minutes, if possible.
Okay, just 1 minute. I want to have the three.
Thank you very much. Thanks a lot, Brother Ramos.
So this is about the FMO user and the DSO user, what exact intelligence is integrated in the FMCT toolkit, so that the FMO user can clear the market in an optimal way and in a network-aware way, and for the DSO user to be able to compose optimal flex requests. And regarding flex suppliers toolkit, we have these three main functionalities: minimize the operational expenditures, minimize the capital expenditures by an optimal flex asset planning algorithm, and the maximization of stacked revenues by its optimized participation in several markets. And at the end, we have this tool for the aggregator. So the main thing is how to manage a given flex request, how to create an optimal flex offer, and how to manage a B2C flexibility market in which end energy prosumers may compete. So this is all from me. You can see more details about the project. You can email me, or you can see here in the social media and in the project website and more about the deliverables that we have published. And that's all from me.
Thank you so much, Prodromos. Well, it have been so interesting the slides and presentations that we are a little bit late. We would like to have more time for questions and answers, but well, we took more time for these interesting presentations. Just to finalize, we will have a couple of questions later or even more. Just as a summary of this presentation, we had 5 different projects with 5 different approaches. Some of them, like HOLISDER Scoop, started more than 3 years ago, so that's why they could present some results and some conclusions of all their work. On the other side, XFlex, FlexGrid and Synergy, which started 1 year ago or less, they were more focused on the objectives and the plans of the project. Some others more focused on demonstration activities. Some others, like FlexGrid, research and innovation actions with different approaches. So one question comes to the audience, and that for me it's also very interesting, and I think for other people that are working on research projects would be interesting as well, is how you think it's how it's affecting the development demonstration process of those projects or your projects, the COVID situation, the COVID crisis. So, well, if I can start like XFlex coordinator. In our case, since it's a project that started this year, for the moment, the main effect is that, well, as everyone, we couldn't organize physical meetings, we could not organize physical dissemination activities. Also, we just started with the preparation of the demonstration sites. So we are having a small delays on this, because we need, for example, to install some smart meters, to install some other equipment in physically. So we stop it during the main crisis of COVID in April and March. So we will probably have a short delay of this. If the situation is getting worse and worse, probably we should have more problems on this. But yeah, we are now trying to advance as much as possible in order to avoid future problems in the future. I would like to ask also these questions to the projects that have more time, like HOLISDER and Scoop, that probably the situation have affected the demonstration activities, and also for FlexGrid and Synergy, what they think it will be the effects. This HOLISDER and Scoop, if you can please go just to the point and do it your answer in 1-2 minutes. Sorry for this, but then we will have more time for other questions. Thank you.
Sure. Thanks, Lola. Well, regarding HOLISDER, actually, the COVID was motivation for asking a project extension of 6 months, because we were right on the validation phase when we find out that many of our buildings, especially the commercial ones, were empty. So we were gathering data from the chiller, from the energy consumption of the building, from the indoor conditions, in some cases of empty offices. So the data was not meaningful for any demonstration. On the other hand, for the residential buildings, it has been the opposite, right? There have been all in Europe intensively using our homes. So that's why we wanted some extra winter to well, when we asked it, we thought that the COVID will not last so much. We thought that we will have a usual winter, but at least we'll see.
Thank you, Pablo. Antonis, what's your experience of this?
Yeah, Pablo, I think gave a very nice overview. So we are in a very similar situation. Well, to see the positive side, we were lucky enough to complete the consumer engagement activities or the user engagement, so it did not affect that part, but definitely demonstrations per se are affected. And I mean, as I said, we need a lot of data from residential premises, and of course, nobody wants anybody else in their house right now. And another critical point also that Pablo mentioned is the representativeness of any result to collect now due to these, let's say, patterns of use of homes, which are, you know, much more extended now compared to the standard case. So I don't know, I mean, we'll see. The Flex Group is also scheduled to end in a few months from now, in 3 months from now. But I think the tools per se and the initial conclusions are valid, but to what extent we can achieve exactly, let's say, the results to the extent demonstrated, this remains to be seen.
Thank you, Antonis. Prodemos? Or
yeah, actually, for FlexGrid, we are in the first year. Let's say we have just ended it, so the situation for us was not so bad because, okay, you know, the first year we were trying to see things from an architectural point of view. So yeah, we didn't have much problem for this specific project, but for other projects that we are working on, especially when they are in the third year or in the last year, there are problems, and such as the ones that the other panelists said. And of course, there is a problem also in the deep technical discussion, let's say. For example, yeah, you know, if you're in a physical place, you can talk to each other in a more technical depth, maybe, and have more fruitful discussions. Yeah, but we are dealing with this issue because, you know, we are people that are keen on also on the physical meetings, which are very important for the consortium. But we are trying to deal with this also with the new situation and many telcos that we have to do every day.
Thank you.
I hope the things will get better.
Sure, I hope so. Luis, any something new to add?
Yeah, well, besides we have just had the first plenary meeting in Synergy last week, so yeah, we are getting used to these online meetings. Besides the telcos and so on, so that to bring something new, we are currently dealing with the deployment plan. So we have a struggle with the identification and characterization of some of the assets, because some buildings and some facilities we were not allowed to get in, so we had to postpone some visits, you know, and that's that has had an impact in our ongoing progress of the project.
Okay, thank you all of you. Raquel, is any more questions from the audience?
Yes, I have one question addressed to Synergy project. Which energy actors will be able to benefit from the project results, and also if you have you are participating in some European related initiatives.
Okay. Okay. So yeah, the first one. If you remember my presentation, there were 3 tool suites. Okay, so the first one was for the grid level analytics. So here we expect to make a positive impact in TSOs, DSOs, regional security coordinators, balance responsible parties, renewables operators, utilities. This is the ecosystem we are facing in this tool suite. In the second one, which is more focused at portfolio level for retailers and aggregators. So we have their retailers, aggregators, but also, you know, flexibility service providers, whichever their nature. And finally, we have also the for the building and district level, we have stakeholders such as facility managers, prosumers, energy services companies, electric vehicle fleet managers. Okay, so as I told, we are trying to cover the whole energy value chain. And with regards to the second question, we are currently participating in the Bridge initiative, okay, which is an H2020 initiative focused on smart grid and energy storage and so on, and digitalization. So we are, Synergies participates here in the data management working group. Well, as you may know, we are providing this architecture, so I guess we can make a positive impact here. Also in the use cases repository, we also participate in the Big Data Value Association. Synergy participates in the steering committee and is nominating partners to be involved in technical and communication committees. And finally, we also are involved in the Open Day initiative, which is also part of H2020. I don't want to go further more in detail. I want to allow for others to have some questions also. But we are involved here by participating in workshops such as the Open Day Energy Domain. And yeah, I think we are quite active so far.
Thank you. I don't know, Mohadis, if we can, it's because it's 1 p.m. o'clock. So if we can take like a couple of minutes for one more question.
Yes, sure, Lola, we can do so because this room will be open to the next conference at 2 o'clock. So maybe 15 more minutes.
Thank you. Raquel, if it's more questions?
There's other questions addressed to FlexRead. Is there a need to correlate sustainability of investments in flexibility assets and the energy market architectures? And how can the regulatory framework play a role in bringing closer the various energy market actors?
Yeah, actually, a long question. Yeah, actually, regarding the investments, the flexibility asset investments, I think that it is as a matter of fact a role of many stakeholders. Many roles should coordinate. Let's say, you know about the European e-directive that says to the transmission system operators and the distribution system operators to publish publicly the report based on which the flexibility investments will be done within the next 5 years, let's say. So all the DSOs should be able to provide this data and this report in order to prove that there is no need for network reinforcements or the flexibility, purchasing flexibility from private owners, flexibility asset owners, is more beneficial. So on the other hand, the transmission system operators do not want to have discrepancies and imbalances in their transmission network. So it's a matter of it's a very complex problem that TSOs and DSOs should collaboratively work on. And also the private companies, as we can understand, they want to maximize their profits. So they want to put the flex assets in specific network locations in which they will be able to solve the problems of the network and maximize their revenues. So you can see the conflicting roles here, because the private investors want to maximize their profits. The system operators want to make sure that the network stability is in place. The regulator wants to have social welfare maximization. So they want all to earn, to gain from this process. The end users want their services to be less expensive at the end of the day, and to have the possibility to sell their flexibility and energy in the markets. whatever small they are. So it is a matter of a very complex issue to design an algorithm and mathematical model, a toolkit that is offered to the regulator, for example, and says that we should put this million of euros in flexibility asset investments in the transmission grid, this X million of euros in the distribution grid, in order to achieve this KPI, which is the social welfare, for example. It is really critical for this, in order for the investments to be sustainable, as we say, economically sustainable, and to make sure that the investments done from the private investors mostly will make their money back, so that the European Central Bank, for example, can give this money to specific governments, and the governments will be able to give them to the transmission system operators and distribution system operators. So it's a very complex issue, and we are dealing with this in FlexGrid.
Thank you very much. There is no more questions from the audience, so let's take a kind of conclusions. Also, because we are 5 minutes even late of our time. Well, that's as you can see, and during these presentations, different approaches dealing with the same problems, but at the end is giving benefits or sharing the benefits of the flexibility of the digital tools to all the actors of the network. Some of the projects were more focused on the customer's side, like on energy cooperatives, like STEPA and HOLISDER, residential sector, but also public sector. Some others like XFlex and Synergy were also leading with tools for the regulated partners like DSOs and DSOs, and also retailers and aggregators. And finally, FlexGrid also focused on the more in the research and advanced models and algorithms to provide an optimal interaction between different actors from market and networks. Also different approaches in the context of some of them are very advanced, also finalized projects. Showing the conclusions and lessons learned today, some models are just starting. We can learn from the other projects, and that's all from my side. If the other speakers wanted to add something as a conclusion. No, okay. So it's having really a pleasure. Thank you very much to the speakers. Thank you very much for the audience. I hope it has been an interesting session for everyone. And we will collaborate in the near future. Keep collaborating. Thank you.
Sure. Thank you, Lola, for the organization. Thank you guys for everything.
Thank you very much. Thank you, our audiences, for being here. Make sure, if you have any more questions, make sure to send it to us. It is already in the chat, sustainableplaces@r2msolution.com. And for making sure to be updated about other Sustainable Places workshops and sessions, please follow us on Twitter, Sustain Places. Thank you very much to our panelists and audiences. Have a good day.
Thank you.
Bye. Thank you.
You too.
Thank you.